Welcome back to solving systems of equations. So far, we've learned how to solve systems by graphing, where if the lines intersect, we know that point is the answer to our system. If they're parallel, it's inconsistent. And if they're the same line, it's infinitely many solutions. We've also learned how to solve systems by substitution, where I ideally have one type of equation that is y equals blah, 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 or x equals whatever, and I can just plug it into the other one that's in standard form already. Today we're going to look at elimination, and elimination, of course, it means exactly what it sounds like. We're going to get rid of a variable. And sometimes we'll be getting rid of x, sometimes we'll be getting rid of y. It just kind of depends on what is easiest. So elimination works best if I have two equations that are both in standard form already. So we'll start with 4x plus 6y equals 32 and 3x minus 6y equals 3. And you kind of see, looking at this plus 6y and the minus 6y, that if I were to add straight down, those two things would cancel. So I'm going to do just that. I'm going to add straight down, and when I do that, 4x plus 3x would give me 7x, plus 6y minus 6y eliminates out. And we can draw that cool little, that goes to 0. And then 32 plus 3 would give us 35. Now that's really easy to solve for x. I divide both sides by 7, and I get x equals 5. Now, if you'll remember, when I'm solving a system of equations, I don't just want x. I want the whole coordinate point where they would intersect if I were to graph them. So I'm going to take this 5, and I'm going to plug it in to one of my equations. It literally does not matter which equation I plug the x into. Just pick one of your original ones. So I like to pick whichever one is easier. If there's like a 1x or a 2 or something small, I usually pick that equation. Here we're doing with 4s, 3s, and 6s, so it doesn't really matter. I see that this one has only a positive, so maybe that'll be a little easier. Don't know. So I'm going to try that one. I'm going to do 4 times 5, because that's what x is equal to, plus 6y equals 32. If I multiply that out, 4 times 5 is 20, plus 6y equals 32. I can subtract that 20 over to the other side. Again, this will cancel. I'll be left with 6y equals 12. Divide both sides by 6. And y is equal to 2. So my answer to this problem, this system of equations, is going to be 5, 2. And that is the point that makes both equations true. Okay, so that's my answer. So let's try another one together, and then I will let you try one on your own. So we're going to start with 5m minus p equals 7, and 7m minus p equals 11. So you see that both of these p's are kind of by themselves, but they're both negative, which is not ideal because if I add down, they will not cancel out. So this is where we kind of have the subtraction side, except for not really, because remember, there is no such thing as a subtraction. It's merely adding a negative. I'm going to make my life a little easier, I'm going to multiply this one through by a negative. So it'd be if I had a negative 1 on the outside, I'm just going to multiply by negative 1. And I distribute that negative 1 to everything in this equation, so it's a negative 5m plus p minus 7. So if you remember when we did adding and subtracting polynomials, it's a lot like that, where when we subtracted the polynomial, we distributed the minus sign through and then added. Okay, same idea here. So now I just distributed the minus sign and I can add down. So I have a negative 5m and a positive 7m. That will give me 2m. A plus p and a minus p will cancel out and go to 0. Positive 11, negative 7 will give me a 4. When I solve for m, I get m equals 2. Now remember, it doesn't matter which equation I plug it back into, and I can plug it into my new top equation or my old one or my bottom equation, doesn't matter. I'm going to plug it into my original top equation. So I have 5m minus p equals 7. And I'm going to say 5 times 2 minus p equals 7. That's 10 minus p equals 7. I'll subtract 10 to the other side. So I get negative p equals negative 3, or that p equals positive 3. And then my point would, of course, be 2, 3. If you're not using x's and y's and you're using something like m and p, the way we put them in an ordered pair is just alphabetical. So m comes before p in the alphabet. That's why it's first in my ordered pair. Okay? I will have you try this one on your own. Do 8x plus 5y equals 38, and negative 8x plus 2y equals 4. So add down, see what you get, plug back in to get the other variable. Good. So if you follow through my work, I have a positive 8x and a negative 8x. Those should cancel straight out. So I'm actually going to start by solving for y. And I get 7y equals 42, y equals 6. I can plug that y equals 6 into my top equation. You can plug it into your bottom, it doesn't matter. I just saw the 5 and that worked for me. And this one had a negative, so I didn't really want to do that. But either one will work. So I did 8x plus 5 times 6 equals 38. 5 times 6 is 30. Subtracted that off both sides. So 8x equals 8, x equals 1. And so my ordered pair is then 1, 6. Okay, and we will practice this more in class and talk more next time about how to use elimination with multiplication so that we always get what we want, and also talking about when is the best time to use each one of these methods. So thanks for watching.